All right, so this is part two. We're gonna get started with the orchestrator. The orchestrator kind of just handles all the orchestration across multiple specialist agents that we have just built. Remember, we had the brand agent, deal pricing, and then vendor. Vendor then talks to legal. So this orchestrator agent kind of just does all the figuring out where to send what, and then if in the case that needs to be handled by human, if this is a case that has been already processed before, it will just delegate it to the agent that needs to be redelegated. That's all. So we're gonna get started with drawing the graph. So we talk about what the graph is, the node and the edges. So here we're just kind of reusing that same concept all together by kind of redoing and drawing the graph. So basically what I'm just asking people to do is just to kind of get started with what's the next step, right? So the next step is ingesting the payload. After ingesting the payload, it will need to dispatch it to multiple agents, right? So we want to head over to find dispatch somewhere. Yep, that's right here. And then it's going to dispatch the workflow or the information into 3 different agents, so they can each individually assess on the actual application of this and doing its audit for this manufacturers. And then eventually they're gonna get merged, and then we have a bunch of other like functions that helps me with validating everything, generating reports, and then at the very end it gets finalized and then returned to the users. So these are just kind of the things that we had before. So like for example, the recovery is must just make sure that we have everything all together. If something goes wrong, I can kind of recover from here, like the recovery endpoints and stuff like that. So this is not so important, but I think the important part is doing the make sure the user knows about the dispatch to send the actual task to multiple agents, and then it gets merged back together. So that's the most important part. So when we talk about these different agents, the most important thing is you want to think about they are all individual agents that sits in its own instance. So unlike the multi-agents we talked about before, like that we have in the deal pricing agents where the actual sub-agents lives inside the same runtime, so there's no so the actual workflow has been handled by a single runtime, so it deals with all the recoveries and everything. But here, because they are in separate different containers or they're running in different places, so it requires A2A communication. And the thing about A2A is that since I think we already went through the A2A, the problem right now is when we delegated our tasks to A2A, we still want to recover from what has been done before. So we want to store these tasks somewhere, and then we need to store that externally. And the way that I did it, like what I said before, is kind of a lazy implementation where because I didn't want to start another database and I don't want to start another web server, so I just hide the whole infrastructure of storing the task inside a Firestore that I already had, and then the endpoint was exposed through the app that we ran. But with A2A, it requires a lot of quick access to the task store, because it needs to retrieve the tasks and then also write to the task, right? So update the task and all that stuff, right? So and it needs to be externally set up because of how our agents are run, right? So remember when we talk about let's just head over to the very last step when we talk about all our agents, right? So our agents are running are deployed into like the agent engines or the agent runtimes, right? So, but they are still kind of containerized in containers, and they are individual instances. And then if you have multiple instances, that if you need to scale things up, that means that you will have multiple instances running the same agent, right, to make sure it's scalable. And then the problem is like when we run the Python, the task store that's default in the libraries, they actually store everything inside the memory. And then because we now have multiple kind of instances that's serving the same agent, if it's if it's been delegated or round robin to a different instance, it is going to say this task is no longer recognizable, right? So it's not okay. That's why we need to make sure that our tasks are stored somewhere else. That's the whole point of why this implementation is done. I'm talking about this because I don't think we actually seen a lot of those implementation before, and then this is something that essentially that you need to do for agentic system. The other things that needs to be remembered or stored permanently are the agent sessions and the agent memories. The agent sessions are the things, all the events that's happening back and forth between the agents and LLMs and the tools. They are all individual events that get stored in each session. And then at the end of the conversation or at the end of the session, we want to make sure we're summarizing all this information so we can use them to retrieve a little bit later. And that's when the Google's agent platform's memory bank becomes super useful, because it automatically summarizes what the sessions and all the events together and store them into memory bank, so that I can use it to retrieve like the past information semantically later on to help my agent to remember what has done previously. So this is something that I also implemented in the orchestrator. Only orchestrator has this in memory; the other doesn't have one. But this is just good to know that this is how it's done, and you can see that from my code as well, right? So and then what else is available right there? So like the way that it has been done is I have set up my Vertex AI session services instead of the in-memory session services, right? So these are all being implemented in my runner. So if you're not familiar with how it's done, you can check out my my actual implementation. Do I have it here? So this, like everything under agent is under the agents folder. But if you actually want to see the actual A2A implementation, I have, because the way that it handles A2A differs like difference between like how the actual implementation is. So you'll see how I have my own implementation of A2A. But with that said, the actual setting of the runner are right here. So you can see like how I store my memory services, and this is how I can persist my memory summaries and all that stuff. It's all here and kind of set up here. So if you're not familiar or aware of how things are done, this is how I kind of wire everything up. And then you can also go back to the memory bank, and you can see that I have my orchestrator set up right here, that I have all my sessions and the resource are writing back into the agent bank, the memory bank, right? So that's what it is. And where is everything? Perfect. And last but not least, what is actually being remembered in the actual memory bank, right? So you want to kind of it remembers all the context of what was in the conversation, right? So when we think about that, it's all about the unit has been sent, where this is coming from, the actual like the toolings and all the things that's kind of like a transaction between like the LLMs and the tools should not be remembered in the memory, because it's not relevant. It's not about it's not about the actual transactional details. It's all about the context. So this is all. So we want to make sure that we remembers all of that. So we ran. So like the things like this is running on like a number of replicas. This is more like infrastructure details. So it should not be remembered as well. This is all, again, this is the workflow has all passed. The workflow should know which workflow has passed, so I can remember which states it is. So this is essential, but completed in completion time, it doesn't matter. Pulling the task store multiple times doesn't matter for users. And then ask users for safety cert. This is more on the side of like, hey, this is more on the human in the loop side. So it should not be remembered coming from the context perspective, right? So that's what's going on. So there you go. You have the orchestrator. Now let's take a look at the front end. So basically what we have so far is the foundational part, where we kind of set up all the the runtimes MCP with the MCP server. We set up the databases. We have all the things stored in Firestore, and then we have set up some of the foundation services like enabling the API for accessing Gemini. And then we set up all the specialist agent where we talk about the branding agent, the brand agent that actually checks the styles, the deal agents that checks with all the deals and the making sure that the loyalties are kind of matched to the actual character itself and all that kind of stuff. And then vendor kind of takes care of the contract, which needs help from the legal. And then we also have the coordinator, which is our orchestrator agent that does all the orchestrations across multiple specialist agents. What's actually missing right now is the front end. So the front end itself is very, very straightforward. So basically what we have so far is that we have a form that looks pretty simple in terms of all the complexity that we are introducing into this workflow. But the problem is there's a lot of unneeded field that will be rendered in the form if I have everything out at the same time. So in order to make it simple and intuitive for user, what's going to happen is that I will render the input field when needed. So this is why I was kind of using the A2 UI to help on this. So if the agents works out pretty well, it will just kind of render the plain JSONs and all that. But what's really cool about this is like once I have a specific view, or I want to render a specific field that needs to be filled from the client side, what's going on is that my agent, my A2 UI, my UI render agent, is going to then render it in the way that the A2 UI client libraries will understand, right? So what I'm doing here is I'm actually generating a prompt by using the libraries coming out from A2 UI. So there in A2 UI, there's a bunch of catalogs that you can use. There's specific JSON format that you can define. And then I can also allow the type of components that are allowed for me to actually use. For example, the one I'm using inside my specific use case are text, card, column, and dividers. That's it. Nothing crazy. And then also other things that's needed, but it is going to generate that prompt for me. So basically what happens is once the information or the prompt gets passed into LLM with the data that was given from all the specialist agent and the orchestrator, it is going to then send it to use the SDK to render all the stuff, and then parse it, and then send it to my application, where my application will then have the A2 UI client library, which is another React app. So it will then render the actual HTML DOM. So that's kind of how A2 UI works, and you can kind of see that from my app. And that's kind of just it. So here I'm just kind of showing you how it works. And the way that the AI render works is that the orchestrator finishes work, then it will call the actual rendering of the visuals. So that's why you'll see like in my app, you'll see like there's the actual process and there's a standalone UI render right here where it just does all the rendering of the front end. So that's kind of it. And then this one just talks about the actual message that's been sent to and from the agents. So if you want to like show people what's actually inside the payload, this is a good place to kind of show people like what they are. And yeah, so this is another payload stuff that you can kind of talk about. So all this is all about like front end UI and a little bit about the payload that's been sent across agents. But that's kind of what this particular step covers. So if you are not a particular fan of like the front end stuff, you can totally skip this one as well. So the next one is all about agent identity and agent gateways, and then the agent registry. So these three kind of they don't need each other, but they kind of go hand in hand. For example, you can like all the endpoints that's available from the registry. The gateway will only recognize all the endpoints exposed by the registry and stuff like that. So this particular chapter covers all the security aspect to it, and how do you actually apply guardrails and apply rules so that to control and rein in your agent so it doesn't go haywire. So basically, there are two types of places, identities that we use here, the agent identity, and then the other one is the service account, right? So what you can see here, the agent identity actually use the SPIFFE standard. Basically, what this means is it's just I look at it as an address for me to figure out where the agent came from, and because of this, then I can kind of go back to the domain of the issuer of the certificate and figure out and make sure that this agent kind of just comes with it, right? So, and then because the way that things works in like Cloud Run and then like Google Cloud Services, things get a little bit like complicated, right? So when you look at how the orchestrator calls an agent through an A2A, so it's calling from agent engine to another agent engine. So it's clearly using the actual agent identity to identify, like to look at their own principle. So they will be looking, the gateway will check the identity of the agent. And then if you think about, the brand style agent calling a Gemini, so this is another one that checks for a Google Cloud Services, but an agent calling a Google Cloud Services. Here we're still using the agent identity because we do know that agent identities and the endpoint from the Vertex will also check the identity as well. But if you talk about a brand style agent calling a tool, because the tool actually runs on MCP server, and the MCP server is running on Cloud Run, Cloud Run actually looks at the things differently. It doesn't have its own identity and everything matched. So it will look at the token. Since our MCP server is behind it's behind a security wall, so that it needs to have a signed token to that. So that's why the agent will then impersonate a service invoker. So this invoker service account will be able to invoke anything on top of the MCP server, so the message can get through. So that's a very special thing happens, especially with Cloud Run and how agent identities and all the agent engine stuff, agent platform stuff connecting to Cloud Run. So that's one thing that kind of happens there. And so that's why in IAMs, you have to pre-create this special service account, otherwise it won't work. And then this is another agent calling the MCP server. So this one is also impersonations. And then if you are calling from MCP server to read a record coming from a special, I think the record is in database, right? So in database, this is going to be just using service account. So we are using service account to access a specific endpoint in Cloud Run. So this is not in Cloud Run, in Firestore. And this one abstracts to a task store, which is, again, it's also under the service account because we are calling from a specific MCP server to the specific MCP server. So this one is just a straight up service account. I'm spending a little bit of time about here because I think it is a bit confusing. An app uploads to a bucket. Obviously, this is a service account thing. An orchestrator reads its own session. So this is orchestrator. It's an agent. It's trying to read its own session into the memory bank. So it's trying to access the agent platform. So therefore, because it's accessing, the agent session are stored, because in our use case, we store everything into memory bank. And then we store everything into Vertex services. So right now, it is inside the agent engine. So it's going through agent engine. So that's why I use this principle. So I just want to make it clear here. And then in order for us to create, to allow the agent engine or engine runtime to use agent identity, is when you deploy, you want to use this configuration, right? You want to use this configuration to config that work and to config that. And then you also want to attach your specific agent to the agent gateway, right? And here in this case, when every time it goes out, this is what it says. When every single time when it's trying to go out from the agent, it will try to go through the agent gateway configuration where we're talking about egress here. So it will go through the agent to anywhere configuration. So this will go through our gateway. So this is kind of how it works and how everything is configured. Very important if you want to set up your agent identity and agent gateway. So these are just some of the services that you do. So that's all agent identities and agent gateway. And now here we want to talk about agent registry. So you can register your service onto agent registry in terms that you can then define different policies, access policies from your agent side, right? So which is like how many, okay, if I have access to this particular MCP server or not. So you need to make sure you have a way to register for it, and these are just different ways. So this is how you can register an MCP server. So basically you can just service create, and basically this is how you kind of register it. And then if you head over to the agent registry, this is how you can see the result, the MCP server. And here this is how it will show up on top of your in your console as well. And same here, if you want to register for an agent, this is how you can go back to the agent, and this is the agent, right? So MCP servers, right here, Vibeflix MCP servers. I have my 3 MCP servers, and then I have my agents, which are the A2A, which communicates in A2A, right? So these are all the configurations that I have. And then if you want to register your specific endpoint, you can do it here. I do have an application endpoints where I'm sending out things to PubSub, so therefore I need to register it. So that's kind of like how I do it. And if you head over to here, to the endpoint, and you'll see like me accessing the PubSub endpoints somewhere. Yeah, so that's kind of it. Where else do I want to show you here? All right, so when we want to go back to talk about agent gateways, in our use case, we are not setting up ingress, because normally what you would put in ingress is just the model armor. So when every single time the user sends in a prompt, it will go through model armor first to make sure everything's protected. No prompt injections or what sort of attack coming in. But since I've already done a bunch of demos on the model armor, I don't want to repeat it again. So here we're just going straight into the agent, and then the egress, which is agent to anywhere configuration, will determine if the agent have access to a specific point. All right, so that's what we had in the egress. And what we want to do is what is being checked inside the actual egress, right? So when you have an agent trying to issue a call outside, it is going to first check who you are. Are you really an agent that's doing all the call? And if it recognizes you, it's going to look into your role and permissions. What kind of permission do you have? What are you? Are you like one of the It will check with the IAM permission and see if you have access to this particular egress. And then once it's done, it's going to look at the destination that you're trying to call, and if it's already registered in the agent registry. If it's not, it's going to reject by default. And then if the endpoint that you're trying to access is the MCP server, and it's a specific tool inside the MCP server, it's going to check if your MCP server is actually, if that tool is actually is in the allow list, so you can call it. So basically that's that. So for us to set up the agent gateway is pretty easy. So all you have to do here is just run the script. So this script does a couple of things. It just checks that if everything is in the service registry, and then it will generate a YAML file based on our configuration. And a YAML file would probably look like this. So that's kind of it for the checkings. All right, so when we get here, we can kind of test our theory, right? So how does it work, right? So our first one is the orchestrator is trying to call the vendor clearance over A2A. So basically, the orchestrator is configured to be able to access anyone inside the agent space, right? So it was kind of set in that way. So it will definitely arrive at the very end. So it will arrive to talk to the vendor clearance, and that's okay. And if you have a vendor clearance that is trying to access MCP server that is not part of yours, because this is the MCP server for branding, that it is going to be blocked. So it is going to be blocked here, right? Because you do not have permission to actually have access to that specific MCP server. So you're going to be blocked here. And then what you're going to have here is that the branding style agent is trying to call a branding audit. So basically, you have an agent trying to access MCP server with allow tool that was configured in your configuration, so it will definitely arrive. And then will have the other one, which is a third-party CLI, who is trying to call orchestrator directly, because our orchestrator, and if the client, it is a client, and the client does have access to access anything, so it will arrive at the very end, because nothing stops in the gateway. In the workshop, we didn't set up any egress to configure that, so nothing will be stopped. It will just go right through. So if you want to add some kind of client to agent aware, kind of become a checkpoint, you can kind of access things from here as well. And last the last two, the deal pricing calls internal pricing. So this is calling internal price, internal API that I don't think it was actually registered. So I'm going to put it here, and it's going to stop right here because it didn't register in the registry. So it's going to try to access that, but since it's not there, it's been hidden inside MCP server, so it won't be able to access that. And last but not least, we have a agent trying to call another MCP server, and this one I think it did not have access so of the tools. So I'm gonna say check if it's not in a tool list, and here we go, we have 6 out of 6 correct. So this is how the agent will stop you, and then if you look at the configuration, this is what the agent gateway looks like, right? So basically you're just setting up your configuration of your gateway and have it to have access to your registry, and you can set up your own identity aware extensions or proxy extensions so that your gateway have access to that specific service. And then last but not least, the policies. The policy can define who and what you have access with, right? And then we want to take a look at the actual policy. It's right here. So if you head over to the policy, you can kind of see all the policies that we set up. So we have set up access from orchestrator to a specific endpoint, from agent registries, has access to some of, so like the regional endpoints are different from the global endpoint, so that's why we have like multiple of them. So that's why. And then because we're using MTLS, we do want to make sure we have the MTLS, and then we have access to all the services that we want to use. So I'm just allowing all of that. And I think one interesting policies that I have in here are the MCP servers, MCP policy configuration, because this actually tells me, like this policy tells me what MCP server I have access to and which tools do I have access to, right? So it does give you that access of like, hey, this MCP server, and I can edit the condition, right? So that's a special thing that this policy can do for you. You can definitely look at all the different conditions that's been configured from this endpoint, right? So some of them would have a lot more access to like other different MCP servers. So these are just some of the configurations I have for running my lab. What else? Yeah, I think I don't think we want to dive into details of like where we're storing the token, because I think it does get a little bit detailed, and I think they will be changing this in the future because currently it's very confusing. I think having to have your authorized token placed in like 2 different places where it does different checking is like it's not very convenient. So I would assume they will be changing that soon. So we'll see how that goes. But basically that covers the whole agent identity, agent registries, and agent gateway. And then last but not least, we talk about tracing. So this is when I walk you through, like if you head over to the deployments, and you get to see the cool stuff that happens underneath the tracing, and you get to see like how the session was running. So I actually ran it like 6 hours ago, so I can check again. So I do have 2 sessions available, and it ran for like a couple minutes. So I have the whole duration of the services. So this one is a little bit longer, so maybe I can change it to a different one that's shorter. Yeah, it does run a little bit faster in terms of different nodes. So you get to see how it's being executed. Less complex, so you can see how the call was done. And yeah, so basically that's kind of it for the observabilities and all that stuff that you want to see. And yeah, so this is cloud tracing, and you can, okay, everybody knows about logging, so I don't have to go through loggings. But yeah, so like you can look at the cloud monitoring if you want to. So if you head over to monitoring, so you can take a look at the log. You can also see the different metrics, and you can take a look at like the cloud run services that you ran, and then the pops up that we had before, and then other other things that we have enabled, and then like different call, different numbers coming from the reasoning engine. You can see all this number coming from that as well. Right now I don't have a lot to show you, but yeah, you can kind of see how everything is right here. So you can set up your own monitoring tools. What else is available here? Yeah, that's kind of like what I had. So what else? That concludes everything so far. And the next step is just having people to kind of play through like different scenarios, the happy path, the path, and then just walk people through the happy path of like it will then do the dispatch, and then it will go through different vendors, and then having everything orchestrated together. And the one that kind of just blocked, it will then be blocked by one of the agents, and then you have a finalized verdict of like you cannot proceed. And then this one kind of just go through the multiple, like maybe just one human in the loop. So it's going to ask you for clarifying questions, and you're going to answer that. So I can quickly take you through one of the services. We can definitely onboard a new vendor. So let's go ahead and onboard a new vendor. And this is the user input that we need. Here it's asking me for the headquarter of this new vendor. I'm going to just enter the new vendor name, where it's located. I'm just gonna say Hong Kong this time. And then what else? Operating region, I'm gonna keep everything the same and then just keep going. So it is going to then figure out which one it will need to rerun. So basically it's not gonna be to rerun all the agents. So it will probably just go for the vendor clearance again. So it's gonna ask like, do you actually need it? Nope, not. The rest of the 2 agent does not need it. So it will then figure out like, hey, I only need to invoke the vendor clearance, and it's going to then go through the whole process. Eventually we'll get a signed contract. And that's it. We have a completed workflow. So in the completion of everything I have installed right now, let me make it a little bit bigger. So we have installed 3 MCP server that each talks to different agents. We have installed agents that connects to apps, right? And then the orchestrator also talks to the app, but then it also talks to the memory bank, the task store, and then it also talks to all the agents. And then we also have the agent identities identify with connecting to IAMs, identify who the agents are. The agent gateway checks, it connects to the agent registry and check if it has access to everything that it has access to. For example, the orchestrator, the vendor clearance would have access to the legal agent and all that kind of stuff. And then what else? We do have our policies with the identity aware proxies that kind of connects to that allow us to connect to MCP server and the rest of the services out there. And then the agent registry kind of just registers all the agents and the MCP server as well. And then we also have the rest of the loggings connected. We also have the monitoring connected, and then the tracing, of course, is used here. And that is the end of the workshop. Thank you for watching. I'll see you next time.